Hello, I'm Sean Blair for ESA Web TV, and I'm here in ESTEC in the Netherlands, which is the technical heart of the European Space Agency. This is the place where engineers and scientists develop the new technologies and missions that are going to go out and explore the solar system. And then once in a while, a little bit of the solar system comes back to visit us. That was footage of a fireball passing over ESTEC. And actually, there have been half a dozen fireballs that we've recorded passing over the technical centre in the last year. So let's go find out a little bit more about them. I'm here now in the offices of ESTEC's Meteor Research Group with science trainee Christiana Smit, who's researching fireballs and meteors. So Christiana, what are fireballs?
So first let's start with what are meteors. So if we've got a meteoroid, meteoroids are small rocky objects that enter the Earth's atmosphere, and when they enter the atmosphere they start glowing and they leave a track of glowing particles behind them, and that's what we know as meteor, or even as shooting star, you would say. And if we've got a really bright meteor, that's what we'd call a fireball.
What made the picture, the footage we just saw?
So we've got a fireball recording camera just on top of the roof of ESTEC, and this camera is part of a network of nearly 100 cameras spread all over Europe, and it belongs to the FRIPON network.
And what does FRIPON stand for?
FRIPON is the Fireball Recovery and Interplanetary Observation Network.
And recovery, that means that you're not just looking at them, the idea is to actually track them down.
Yeah, that's the point. So if we've got not just one camera observing the fireballs, but two or more cameras, we can find out about the orbit and the trajectory of the fireballs. And then we can figure out, okay, where did the meteoroid land on the Earth, and figure out what's the composition, find it. That's the goal. But we could also follow the way back and figure out, okay, where did this meteoroid come from? Was it from a comet or an asteroid? And because these bodies are as old as the solar system, we could find out about the history of planets, or even how life was reaching Earth.
Right. And where is the camera exactly?
It's right here on top of the roof.
All right, well, let's go take a look. Well, I'm up here now on the very top of ESTEC to track down the FRIPON camera, and here it is. And I'm up here with senior data technician Andrea Toni, whose job it is to maintain the FRIPON and the system behind it. Well, Andrea, the camera itself is quite small and compact. What's actually inside it?
Yes, the camera is quite small. There is a CCD on top, which is taking images, 30 frames per second. And inside there is an Ethernet controller, which with just one cable and the power is sending down the images to a computer which is recording 45 days of data. The look of the camera is a fisheye, so you can cover 180 degrees. And yeah, this camera has been here for 1 year and a few months, and we already got 6 detections with them.
What do you do about things that aren't fireballs? Airplanes, birds?
Now, obviously, the planes and birds are very slow in moving, whereas the meteorites and fireballs are quite fast. So the software is very smart, and it can detect in the frames all this speed. This is a French project, and it started in France, and they have already more than 100 cameras in France. Here in Holland, we started just last year. We have one here, one in Oostkappel. But we do plan to expand, of course.
And what's the advantage of having more and more cameras? What does the project get out of it?
Well, the geographical coverage of one camera is an area of around 100 kilometers. So if you really want to have multiple detection and cover a big surface, you need one every 100 kilometers. So for Holland, we plan to install 8 more. It's very nice when we have multiple detections, because then we can compute the trajectory and the orbit in a better way. And it's easier to see if it's something which is fall down on Earth, where the position is.
So that's the real goal, to actually one day find something based on the camera detections?
Yes, indeed. It's very nice to find something, to see the structure of whatever fell from the sky, to see how it is made and composed, and try to understand how these meteorites or fireball are made of.
So that hasn't happened yet, but that is the long-term goal of the project?
Yes, indeed. Not yet in the Netherlands, but we are looking forward to get more of them.
Well, fingers crossed and best of luck. I think we'll go down now. The nearest neighbour to ESTEC's fireball hunting camera is about 80 kilometres away as the crow flies in the westerly Dutch province of Zeeland. We've come here to take a look. We're standing now in the small Dutch village of Oostkapelle, close to the sea. So this FRIPON camera's in a very different setting. This farm belongs to Klaus Jobser, who's taken advantage of the dark skies around Zeeland to devote his farm for amateur astronomy. It's called the Cyclops Observatory, and it's a well-established part of the Dutch astronomical landscape. And since last year, among his other cameras and telescopes, he's also been hosting a FRIPON camera here. How did you get involved with FRIPON?
I was on a congress a few years back, and I met François Collat, who was the founder of the FRIPON network in France. I heard that he was trying to expand the network to the north, so I said, okay, François, count me in when you are ready for that.
And to explain, you've been a keen amateur astronomer for a long time.
Yes, that's true. I've been amateur astronomer about 50 years now, and well, I've always lived in this area. Quite dark sky. You can see the Milky Way with the naked eye. So it was easy to get involved.
Asteroid observation is one area where amateur observations are very important.
Yes, that's true. Because on a quite simple way you can collect data, scientific valuable data, with the telescopes. I'm an amateur, so it should be fun. But it's also a bonus to have some data which can be shared with the scientific community.
In the background here we have a fair few cameras. There's this big telescope here, there's the FRIPON. You also have these smaller cameras here. So what are the other cameras for?
The other cameras are part of the CAMS network in the Netherlands and in Belgium. They film and photograph smaller meteors, so not the big particles which FRIPON is aiming at, but the more smaller ones, and we have a network in the Netherlands and in Belgium, and collecting quite a lot of meteors every night.
So you've had the FRIPON since last October. How much has it seen so far?
Well, we have 5 events which were multi-station. Last week we had one multi-station event which was photographed by Oostkapelle here, Brussels, and some northern France stations.
All right. And what do you yourself have to do with the camera?
Well, very little. I have to provide power and good space, and then the data goes directly to Marseille. And when there is a good event, I get the data back from France.
All right. And they're looking to expand the network further. Would you encourage other people to maybe see if they can get involved with FRIPON?
Oh yes, certainly. The more stations, the better for a good coverage of the sky above the Netherlands. So it's very good to have more stations, yes.
Well, thanks a lot for showing us around. This is Sean Blair for ESA Web TV, signing off.